So chapter 12 deals with surveys, okay? Chapter 13 will deal with experiments. So when you're doing a survey, you're generally trying to estimate something about the population. The population is the entire group of individuals or instances that we hope to learn from. The population is everybody at Elsinore High School, everybody in Lake Elsinore, everybody in the United States. It's a huge cloud of people that you couldn't possibly get everybody's opinion about, right? So we take a sample, a small piece of our small group from that population. A sample is defined as a representative subset of a population. Okay? We examine it in hope of learning something about the population. Okay? So, a sample survey is a study that asks questions of a sample drawn from some population. If the sample is not representative, then the information you get from the survey is misleading. Okay? If I just survey my AP Stats class about whether or not they like math, I'm going to get a very different opinion than I would if I did a sample of everybody on campus, right? Those that are in an AP math class don't generally have the same opinion of math as those that are in lower math classes, right? So it's important that our sample be representative, and there are certain ways to help make sure that our sample is representative. Bias is when a sample does not represent the population in an important way or overlooks an important group. We must avoid bias above all else. A biased survey is useless. There's no way to fix data that's been biased, and there's no way to salvage useful information from a biased survey. So we have this term in statistics, it's called sampling error. And in most math classes, when you hear the word error, you think mistake, right? And that's not what this means in statistics. Sampling error is also known as sampling variation, natural variability in the results that are observed from one example or one sample to the next. If I do a sample today of, say, 50 students on campus, I'm going to get a different result than if I did it tomorrow, because I'm going to have a different group of people answering the question. That is sampling error. There's nothing wrong with it. It's natural and it happens. It's going to be different every time you do it, okay? And that's okay. Every sample produces different estimates of the population. Okay? That's why during election season, 1 week they're going to say that this person is in the lead. The next week, the numbers change, okay? Because they asked a different group of people every time. And they're trying their best to get a good representation of the voters in the country, right? But there's all kinds of things working against them when it comes to that. So one of the best way to protect against bias is randomization, okay? Each individual needs to be given a fair random chance of selection. It protects also against effects we are unaware of, okay? A survey that matches is any attempt to force a sample to resemble specified attributes. For example, say our campus is 20% seniors, 25% juniors, 25% sophomores, and 30% freshmen. If we were going to do a matched survey, we would try to get a sample that had 30% freshmen to match the representation in the population, 25% sophomores, 25% juniors, and 20% seniors. That would match the population distribution, so we would maybe get a better idea of the opinion on campus about something. Simply because maybe whatever you're asking, a freshman is going to have a different opinion about than a senior. Okay? A census is a sample that includes the entire population. Okay? When we do when we get SAT data for our students, we have a census. We have everybody's SAT score. There's no reason to sample. When we have CASP data, we have everybody's CASP data. We don't need to sample that data. Okay? The census is done every 10 years. So next year will be another census year. Okay? And I found out that there's like 3 questions on it. I thought it was going to be this big, long thing, and really you just give them your social security number, and then they get all the data anyways. You don't have to answer anything. So the sample size is the number of individuals that you sampled. Now we have 2 different things. We have a parameter and a statistic. Okay? A parameter is the population attribute. Okay, it's the population proportion, the population mean, the population standard deviation. Those are called parameters. They represent the entire population, and we rarely know them. We rarely know the average number of television hours watched for the entire United States. Okay, that's not like easy data to gather. So the population, any kind of numerical attribute that we calculate about the population is called a parameter. And we use Greek letters for parameters, and then we use other letters, our letters, for statistics. The statistic comes from a sample. The sample population, the sample proportion, the sample mean, the sample standard deviation, the sample median, those are statistics. Values calculated from the sample data. We want to be able to use these to estimate the parameter. So we're using our sample mean to estimate the population mean. A statistic is representative if it accurately reflects the corresponding population parameter. And now we're getting into the different kinds of samples. Okay? So I'm going to skip simple random sample. The sampling frame is the list of individuals you are sampling from. If I have a list of every student on campus and I'm sampling from that, then that is my sampling frame. Okay? If I have a list of all of the voters registered in Lake Elsinore, that is my sampling frame. So who am I sampling from? Where am I getting the information from? A simple random sample is when any subset of the population has an equally likely chance to be chosen. In a simple random sample, say I was going to do a simple random sample of Elsinore High School, I would number the students from 1 to 2,000 whatever, right? And then I would randomly generate however many numbers I'm interested in, say it's 100, okay? I would randomly generate 100 numbers, and the corresponding people with those numbers would be my sample. Everybody had an opportunity to be chosen. We didn't divide them up. When it says any subset, that means we could have any combination of 100 people that is possible. Any of the combinations are possible. That's a simple random sample. The next one is called a stratified random sample. Stratified is when we divide the population by a variable that we think might affect the sample. For example, what if my question might be different, answered differently among the grade levels on campus? I think freshmen might have a different opinion from the sophomores, the juniors, and the seniors. So I'm going to stratify my sample by dividing up my population by freshmen, and say I'm going to have 25 freshmen chosen from that list. I'm going to randomly sample 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors. Not every subset could have been chosen there. We couldn't get a group of all seniors if we are to stratify our data by grade level. In a simple random sample, it's unlikely to get a group of all seniors, but it is still possible, and they still had a chance to be one of the groups. Okay? So your stratified sample says, I think maybe whether you are male or female is going to determine how you answer this question. So I'm going to sample 50 males and 50 females. Okay? The groups are homogeneous in some important variable. What if I think your eye color affects the way you might answer this question? So I'm going to ask this many people with blue eyes, this many people with brown, and this many people with green or hazel or other. Is there more than the 4? Okay, we randomly sample within the strata. Okay, so strata are homogeneous. They have something in common. Okay. Questions so far? We're going to do a couple of activities that are going to help us kind of see the difference between these. Okay. The next type of sampling is called a cluster sample. This is where we sample an entire group that are chosen at random. Clusters are usually chosen by convenience. Clusters are heterogeneous within. Okay, so our strata were homogeneous. They had a common variable. Our clusters are mixed up. Okay, so for example, I wouldn't want to take, say, math classes and then randomly choose a math class as a cluster, because most of our math classes are concentrated in 1 or 2 grade levels. Okay, for example, this one is mostly seniors. We have a few juniors in here this year. Okay, Algebra 2 is mostly 10th and 11th graders, and we have some seniors in there. Right? Geometry is mostly 10th graders and freshmen and so on. Okay? So we wouldn't really get a completely heterogeneous grouping if we chose math classes. Can you think of classes we might be able to choose that would have a more heterogeneous grouping?
AP Psychology.
Arts?
Oh.
AP Psych?
Oh, no.
I don't think AP Psych has freshmen.
No, you're right. Human geography.
Science, maybe? Maybe your science classes, art classes, PE, maybe athletics, right? The athletics classes have a pretty good variety, maybe. So those would be clusters. And when you do a cluster sample, say I randomly choose Miss Metter's class, okay? I'm going to sample everybody in her class. I'm not going to randomly sample within. I've randomly chosen her class, and her entire class gets sampled. Okay, so in a cluster, the cluster's randomly chosen, and then you sample everybody in the cluster. Okay. The more clusters you have, the better. And clusters should be similar to each other. Okay, the 4th type of sampling is called a systematic sample. Okay. In a simple systematic sample, we select individuals systematically from the sampling frame. Okay, but the sampling frame must be random. Okay, we can't do a systematic sample from an alphabetized list. For example, we might start at the 5th student and then choose every 29th student that walks by us. Okay, I don't know if they still do this at the mall, but I used to come up the elevator and there'd be someone there waiting there with a clipboard. You guys ever remember this? And you'd walk by and you'd wonder if they were going to ask you. And sometimes they didn't. And sometimes they did stop you and they'd ask you questions. Hey, do you have time for a quick survey? Right? But sometimes you'd walk by them and they wouldn't ask you. And you're like, well, how come you didn't ask me? Right? It's because you weren't the right person. He's counting every 5th or every 10th person that comes up the escalator, and when he counts the 10th person, that's the person he's going to contact to get his information. Because it's too hard. I can't number everybody at the mall and then randomly seek out person number 10. Hey you, can I give you number 10? That doesn't work, right? So a systematic sample, and this is the kind of sampling we're going to do for our project. Okay, our project comes pretty quickly in this unit or this class because we deal with sampling. Okay, we deal with bias, and we're going to investigate some response bias. So you're going to stand at one of the gates on campus. You're going to select, in your calculator, you're going to use randint. Let's just say, we don't want to do every first person or every other person. That's going to be too hard, right? So we're going to do, say, randint 3,15. Okay? And we're going to randomly generate. Can you do that for me, Hannah? Randint 3,15. That's going to represent our interval. How many people are going to walk by before I ask another question?
How many numbers?
Just one. 5. Okay? So that represents, I'm going to ask every 5th person that walks by me. Okay? But if I do that, people 1 through 4 didn't have a chance. Right? People 6, 7, 8, 9 never had a chance to be chosen. So now we need to pick our starting point. We need to randomly generate a starting point between 1 and 5 so that everybody had an opportunity to be chosen for our survey. Okay? What do we get? Randint 1, 5? Yeah, 1,5. One. So if we got 1, that means we're going to start with the first person we see. Okay, the first person we see gets asked our question, and then our interval is 5, so then I'm going to ask every 5th person after that. So the systematic survey is like a practical way to do surveys when you can't get a list of the whole population. Okay. Now a multi-stage kind of combines several different types of sampling. Maybe you are separating your data by male and female because of the way you're asking, what question you're asking. So you're systematically sampling in between the strata, right? So you're doing 2 different things. You're stratifying by gender, but you are systematically sampling within there. That's multi-stage. And the last one is the one you don't get to do, that we shouldn't be doing, a convenience sample. Okay? And I believe there was a class on campus that did some kind of surveys.
What if the 5th person is someone you know?
That's okay. It's okay if the person randomly selected is someone you know. But you can't just be like, ask my friends at lunch. Right? Because, generally our friends have similar opinions to us. Okay? We tend to surround ourselves with people that have similar opinions, that have similar beliefs, because that just makes life a little bit easier. Right? It's kind of hard when someone doesn't believe the same things as you and you're butting heads all the time. Right? If you start talking about controversial topics and stuff. But a convenience sample is I'm just going to ask my family and friends. Well, that's not representative of the population you're interested in. Right? It has to be random so we can represent the whole school, not just our friends' opinions. Okay? These 2 websites, Gallup, Rasmussen's reports, you've probably heard of Gallup before. They are a huge national organization that just gathers data, right? They're probably the ones that are calling you all the time asking you to take a survey, right? And I feel bad sometimes, usually when we're in this chapter, I kind of feel bad, so I'm like, okay, I'll answer your survey questions. And then later on in the school year, I'm like, no, I don't have time for that, But That's a type of, Gallup does surveys. You can go to their website and see all kinds of stuff. They generally sample over 1,000 people for every survey. And it's usually like random digit dialing. They have machines that randomly choose phone numbers and they call that phone number. Okay. Now, what are the different types of bias? Okay. There are 3 main types of bias: under coverage, response bias, and non-response bias. Okay. Under coverage is also known as selection bias. This is when members of the population don't have the same chance of being chosen. Okay. I have an article about how cell phones are screwing up their ability to do these random digit dialing surveys because they're not supposed to allow you to. They're not supposed to be allowed to call your phone, your cell phone, because you get charged minutes for that, right? Nowadays, most of our plans are on unlimited minutes, right? So if they've like laxed up on that, it's because you're not actually paying for all your minutes. Your minutes now, talk-wise, like, I mean, how often do you talk on the phone? I avoid like talking on the phone as much as possible, right? I'm like, if I can do it through text, I do, right? Except for like that 1 or 2 friends that like, she just talks my ear off for like an hour. My husband's like, you're always just like, yeah. Because she's like, he's like, you're such a good listener. Okay, so, but more and more of us, more and more of our families don't have a landline anymore. Right? How many of you have a landline at home? I do. Okay. I did until about 2 years ago. Okay. But more and more people don't have that landline, so now anybody that does not have a landline cannot be chosen for these surveys, and that's under coverage. You're not represented in these surveys because you can't be reached by that landline. Okay? Which I'm pretty sure they're eventually going to start calling cell phones, which is even more annoying. But now, one form of under coverage is voluntary response bias. Okay? This is call in and vote for your favorite performer. American Idol, America's Got Talent. This is all voluntary response bias, right? Can you get enough people to care enough to get on their phone and vote for you? Okay. Never in my life have I voted until last week. I voted for Cody. Okay. Never in my life have I voted for anything like that. Never in my life have I watched these shows until this year. But this type of response bias happens a lot. Okay. Twitter surveys, those are all biased. Okay, because you have to want to answer the question enough to click on that link and go and answer the questions. Okay. Any kind of survey at the end of your receipt at Jack in the Box or Sonic, or get your free code for a free soda, right? You really have to want to go and give your opinion. Okay? Reviews on products. Do you think they're slightly biased? Most of the time you find that reviews on products are people that really love the product enough to want to go write a review about it or hated it, right? There's not a lot of in between sometimes, right? So when you're reading those, and I'm not saying I don't read them, right? I want to know what's gone wrong with this product before I spend my money on it, right? I want to know what people thought about this restaurant before I go there for the first time, right? Yelp reviews. You got to want to spend your time to give your opinion. That's voluntary response bias. Not everybody that goes is required to tell the world what they thought about that restaurant or what they thought about that product. Okay. So that's the first type of bias, under coverage. Not everybody had a chance to be a part of the survey, okay, either by choice or because they don't have a cell phone, right? Response bias is the second kind. Response bias is when there's something about the way the question is worded that kind of steers you to answer a certain way.
Brilliant.
Okay? Or something about the person that's asking. I go to each person, do you like AP Statistics? Do you like AP Statistics? Do you like AP Statistics? I'm your AP Stats teacher. You better tell me yes. Right? Some of you are going to be influenced to say yes because I'm your teacher and I do your grade. Of course I like your class. Right? Some of you are like, no, this class sucks. Okay, well, you can go then. Just kidding. But there's something about the person that's asking the question that influences how people are responding. And this is the type of response bias we're going to investigate. And it's actually kind of fun because you're going to create it. Okay? You're going to purposely make your survey biased. Okay? You're going to change the way it's worded so that people are more likely to answer a certain way. You're going to change something about how you dress, right? We have football players put on their football jersey and be like, do you support us in our football? Yeah, of course I do. Go to the little freshman. You know? Wanting to please the surveyor, wanting to be politically correct. The wording of the choices, the order of the choices, leading statements. Okay, new research says that diet sodas are bad for you. Do you drink diet soda? Okay, no, right? You can see how that can influence someone to answer untruthfully, right? Now you don't know whether their answer was truthful or not, but you could see how it would affect them. Forcing to extremes, okay? I'm going to print this Holocaust article. It's really interesting, or maybe I'll just read it to you. Yep.
So, I read an article that was talking about the statistics of people cheating on their spouses. Well, could that be a response bias because it's really a personal question?
Absolutely.
Okay.
A very personal question, and whether the question is anonymous or not, right? Can I have your name before you ask the question, right? Do you smoke marijuana? Do you think they're going to answer truthfully? They're probably more likely to say no, right? Or, can I have your name? Have you ever cheated on a math test? Right? If you ask their name first, their anonymity is gone and they're unlikely to be truthful. That's response bias. Okay, there's lots of different forms of response bias. Okay? Standing outside of a bar. Do you think drunk driving is right as they're getting into their car? Right? Yeah, probably not a good idea to ask that question there. Okay? And the last one is called non-response bias. Okay? Very different things. Response bias is you're being influenced, your response is being influenced. Non-response bias is people not answering. Every survey is going to have some non-response bias. Okay, people are going to say, no, I don't have time to answer your question. People are going to hang up the phone, right? People are going to say, I'd rather not answer that. Okay, non-response bias is people not answering the survey. Okay, not answering the phone, not returning a printed survey. All surveys suffer from non-response bias, right? If it's a little bit, you're okay. But if I send out I send out 2,000 surveys to every parent in our school, and I get back 100, okay? That's a really large non-response bias, right? 1,900 people didn't respond. Am I getting a good representative answer? No. Okay, so you can follow up, and that can usually help with non-response bias. Okay.